Welcome to Learning is Fun. I'm going to be talking about LCM and HCF and their applications. Before I progress further, I would like to let us know some previous knowledge that we should have known in order to solve LCM and HCF. Firstly, we need to know numbers, e.g. prime numbers and whole numbers. This might look funny, but in real sense, we would notice that we actually need to know them. Also, we need to know how to multiply and divide, because this is the major arithmetic operation that is involved in both LCM and HCF. Then I'll finally discuss about the applications of LCM and HCF, because in real sense you will see what they can actually do, how they can help us. So to start with, let me do a review on prime numbers and whole numbers. Prime numbers have only two factors. Take for example, if we have this list of prime numbers whereby we multiply some numbers which would actually give us the prime numbers. And for us to have prime numbers, we have to multiply only two whole numbers. We can actually multiply fractions to give us the prime number, but in the case of prime numbers, the definition of prime numbers, we have to multiply two whole numbers to give us the prime numbers. And the only two whole numbers are 1 and the prime number itself, which makes the factor of the prime number. And let us take for example, we have 1 multiplied by 2 actually gives me 2. 1 multiplied by 3 gives me 3. 1 multiplied by 5 actually gives me 5. 1 multiplied by 7, and it goes on like that. So here now we have our answers, which are the prime numbers, and we can also call them multiples. Why? The numbers we multiplied are actually called the factors. These are actually called the factors. So these are the only two whole numbers we multiply to give us these prime numbers. So we can actually say 1 multiplied by 2 is the prime factors, or are the prime factors of 2. 1 multiplied by 3 are the prime factors of 3, and it goes on like that. This now brings us to multiples and factors. When we multiply two whole numbers to give us a particular number, the numbers we multiplied are the factors. So we have it here. These are our factors of each of these numbers here, and the answer we get after multiplying those numbers, which are the factors, are what we call the multiples. So this now brings us to our topic for today, which is LCM and HCF. So to start with, let me talk about the definition of LCM. LCMs represent or means lowest common multiple, or in other words, it could also be called least common multiple, while HCF means highest common factor. So in finding the LCM of a list of numbers, we try to find or figure out a common multiple that is actually the least or smallest among it. So let me take for example, if we were to find the LCM of a certain list of numbers. So right here now, if we were to find the LCM, find the LCM of 6, 4, 8, 12. What you actually have to do here is, for those going to list out the multiples of each of these numbers, And when we list out the multiples of each of these numbers, we will now find the one that is common among the multiples of each of these numbers, and we'll circle out the least common multiple. So this method, we just need to list out the multiples of each of them. So let me start from the first number. And if you recall what I said about multiples are when we multiply a certain number by another number, so the answer we get gives us the multiple. So when we just do our multiplication of 6 by different number, we get the multiples of 6. So 6 multiplied by 1 gives me 6, by 2 12, by 3 18, 24, goes on like that, 30, 36, and I'll just stop there and I'll just put 3 dots to represent it being continuing like that. The next number being 4, I would have 4 here. 4 multiplied by 1 4, by 2 8, by 3 12, 16, 20, 24, and goes on like that. I just put on 3 dots to represent that. Then the next one will be 8, which is going to have multiples of 8, 16, 24, 32, and 40. I'll stop there and continue going on like that. Then the next one, 12, that will be 12 multiplied by 1 12, 24, 36, 48, and I'll stop there. It just goes on like that. So I actually stop because I can actually notice that there's actually a certain number that is common among each of them, and that's going to, if you notice it, you can see that we have 24, but you first have to observe if there is any number that is common that is lower than 24, and we don't have that. So you can just see that 24 is actually our common multiple and is actually the lowest among all of them. So I can actually circle this. So this is 24. You can see 24. You can also see here 24. You can actually see here 24. Therefore, this now gives us our LCM of this list of numbers to be 24. So using another method which can be called the branching method, what actually happens here is just that you just draw a kind of branch. You write out the numbers 6, 4, 8, and 12. Using this method involves you dividing the numbers by factor to another whole number until it gets to 1. But in most cases, I prefer to use prime numbers in the order they occur because they only have 2 factors compared to other numbers. So dividing this list of numbers here by a certain prime number goes on like that till we have 1 at the bottom of this branch. So that's just how this method works. So I'll start with the first prime number, which is actually 2. So 6 divided by 2 would actually give me 3. 4 divided by 2 gives me 2. 8 divided by 2, that will be 4. 12 divided by 2, that will be 6. I can notice that 2 can divide some numbers here because we have some even numbers here. So I use 2 again. I can't use 3 to divide 2 because this wouldn't give me a whole number back. This will give me a whole number and a fraction, which is also a whole number and a decimal. So I'll just return 3 back. 2 divided by 2, 1. 4 divided by 2, 2. 6 divided by 2, I have 3. I can still see that 2 is still present, an even number. We have 3, 1, 1, then 3. The next number to use here now is now going to be 3. This will be 1, 1, 1, 1. So I can notice that I have these factors out here. So what I will just actually have to do is just to multiply them back, and that will give me my LCM. So my LCM is actually going to be equals to 2 multiplied by 2 multiplied by another 2, multiplied by 3. So 2 multiplied by 2 is 4, by 2, 8, 8 times 3, that will give me 24. I prefer the branching method because of it is faster and saves time. So let us now look at an example on HCF. So since HCF is about factors, we need to list out the factors of each number. So let us take, for example, to find HCF of 16, 24, 20, and 20. So what we actually do here, we just have to list out the factors. And listing out the factors, if you remember, we are trying to list out the numbers we can multiply to actually give us 16. So I'll start from the first number that we can actually use to get 16, and that will just be 1 multiplied by 16. The next one will be 2 multiplied by 8. The next one will be 4 multiplied by 4. So from here now, I'll just form something like a cup backward, giving me a kind of U-shaped arrow curve. So listing out the factors, therefore the factors of 16 would actually be 1, 2, 4. I can't repeat 4 again because I'm going upward like this, 8 and 16. So for the next number now, which is 24, listing out the factors, starting from the first one, that will be 1 times 24. The other one will be 2 times 12. The other one will be 3 multiplied by 8. And 4 multiplied by 6. So doing this U upward back, we have something like this, and this gives us the factors of 24, which would be 1, 2, 3, 4, 6, 8, 12, and 24. So you can actually see 24 have a lot of factors which we have written out just by knowing the numbers we can multiply to actually give us 24. So the last one here now is actually 20. So I can do that here. 20 is actually equal to 1 multiplied by t, 2 multiplied by 10, and 4 multiplied by 5. So forming a U back upwards. So this gives me the factors of 20. So 20 will be equals to, we now have 1, 2, 4, 5, 10, and 20. So from here now, we have the factors of each of these numbers. So but what you can see that we have so many common factors, but what we're actually looking for here is just the highest common factor. And if you can see the highest common factor among all of them, you can see that 1 is common, is a factor of each of these numbers. 2 is also a factor of each of these numbers, and 4, but we need to choose the highest. So the highest among each of these numbers excuse me, is actually 4. So I can circle that out. So you can see it 4, you can see it 4, you can see it 4. So therefore our HCF would actually be equals to 4. So now using the branching method, which can also work in HCF, but in this case, unlike LCM, we need to find a factor that can divide through all the numbers at the same time. And also, it's not compulsory that the numbers at the bottom of the branch all have to be ones. So we just need to find a number that can divide through all the numbers at the same time. So let me draw out my branch. So we have that. So from here now, I can list out my numbers. So I have 16, 24, and 20. So here now, if I look at these numbers here, 16, 24, and 20, I can see that they are all even numbers. So it is by fact that 2 can actually divide through all of them. But I'm just actually starting with 2, but normally you could just notice that 4 can actually go through them, but it's better for you to start it step by step. So from here now I can just write 2, and this will give me 8. Here will be 12. Here would also be 10. I can still notice that they are all even numbers, so 2 can still go, can still divide through all of them, and I'll have 2 here again. So 8 divided by 2, 4. 12 divided by 2, that will give me 6, and this will be 5. Actually here now we have 4, 6, 5. So the only factor that can divide through all of them and give us back a whole number is actually 1. So it will just keep on repeating the same whole numbers back. Yeah, so we don't need to write 1, so we can just actually stop here. But in a case whereby we're given a list of numbers that seems to be all different, that we can't figure out a number that is actually going to go through all of them, what should just come to our mind is that 1 is also a factor, so we can just write our HCF to just be 1. So from here now, using the branching method, I'll just multiply out the factors, and that will just give me 2 multiplied by 2, and that will give me 4. So therefore you can see that using any of the method, you'll still get your answer, but branching method still supersedes to be the faster method between the two method of solving both HCF and LCM. So now back to the applications of LCM and HCF. So LCM are used in addition and subtractions of fractions, and also to determine the lowest fraction among a certain list of fractions. So that's the application of LCM. With the aid of LCM, you can actually use them to add. Let me write that. So I can use this to add, subtract, and determine the lowest fraction among a list of fractions. So that's just what you can majorly use L to do: add, subtract, determine the lowest fraction, or you can try to determine the highest fraction among a list of fractions. Whereas HCF is used to factorize an algebraic expression. So you just use it to factorize. This is actually used to factorize algebraic expression. So that's it about LCM and HCF. So if you have any suggestion or comment, you can just kindly drop them below. And if you found this video educative, you can click the like button and subscribe. Thank you.